This is a two-part problem. An office supply company sells X permanent markers each year at a price of P dollars per marker. They estimate that the price demand equation for these markers is P equals 10 minus 0.001X. What price should the company charge for markers to maximize revenue? What is the maximum revenue? And then the next part will involve cost, but we'll do the first part first. Okay, so our function, we're trying to maximize revenue. We have a price demand equation. We are interested in revenue, so we know revenue is equal to P times X, and we can substitute P here with 10 minus 0.001X times X, and that's simply 10X minus 0.001X squared. Okay, so that's our revenue as a function of X. We want to find the maximum revenue, which means we need to check here what is the range of valid X values for our price demand equation. Clearly, the smallest X that we can have is 0, and then the largest X, if we want 10 here, is 10,000. Right, so we put it X equals 10,000, 0.001 times 10,000 is 10, and the price is 0. So this is our range of valid X. Remember, if we want to maximize something, we need to check the boundaries as well. Okay, so we've got the function we want to maximize, we've got a range upon which we want to maximize it, and so we're going to maximize by taking the derivative. So r prime of x is equal to 10 minus 0.002x. We look for critical numbers. 0 equals 10 minus 0.002x. 0.002x equals 10, which means x equals 5,000. So 5,000 markers. We have a single critical number here, and we can just look for a second. Let me draw my number line. So 5,000. And we want r prime of x, and we ask ourselves, to the left of 5,000, say, within our 0 to 10,000, so let's put 0 in. Put 0 in, we have a positive r prime, right? We put 0 into this function here, and we have 10. And if we put x equals 10,000, then we know this here is 20, so we get negative. So the function is increasing here, decreasing there, increasing, decreasing, which means this is a maximum. So the number of pens to produce is 5,000. The price of the pen is 5, right? So P is equal to 10 minus 0.001 times 5,000, which is 5. So that's our price. And our revenue is 5 times 5,000, or 25,000. So we have maximized our revenue. Next, we're going to do the same thing, but this time we're going to include our costs. So the company has a manufacturing cost of 5,000 plus 2x. And we want to know what is the company's maximum profit, what should they charge per marker, and how many should they produce. So this is roughly the same problem. So profit is equal to revenue minus cost, which is equal to 10x minus 0.001x squared minus costs, which are 5,000 minus 2x. We simplify and we get 12x. Let's just check this here. Hold on a second. This is 5,000 plus 2x. So we get 8x minus 0.001x squared minus 5,000. Again, our valid range is x is between 0 and 10,000. And we're going to find critical numbers. P prime of x equals 8 minus 0.002 x. So we have a critical number at x equals 4,000. Again, I skipped a step. We set that to 0. We solve for x. We find x equals 4,000. Again, we can draw our number line. There are plenty of ways to do this, but we're doing the number line approach here. So we put in 4,000, choose a number to the left. 0 seems like the easiest one. The derivative of profit is increasing. Choose a number to the right. 10,000 seems like an easy one. Again, we get decreasing. So the function is increasing. The function is decreasing, which means that x equals 4,000 maximizes profit. When x equals 4,000, P equals 6, and the profit is equal to, let's see, the revenue is 6 times 4,000, 24,000 minus 5,000 plus 8,000. So 24,000 minus 13,000 is $11,000.